Okay, so now we have a good little application problem for composite functions. So what I want you to do is take a quick read of sample problem number 5 and do your best to try to work the entire problem if you can. It's understandable if you don't get it on your first shot, but it would be a good practice. I'm going to give you one hint here. It does require composite functions, which means you have to have the individual functions first, and you are going to be required to come up with those individual functions. So I'll let you get started on this, and I will slowly give you the information needed, and you can come back and watch the solution in parts to kind of give you hints. Okay, so what I've done here to start is I've created a variable to represent the dollar value of a large pizza, and I just simply used X. And I created two functions to represent the different types of discounts that I could get when buying a large pizza. The first one is the coupon method, where you see I just generically use C of X for the coupon function. And simply we're taking the large pizza dollar amount and we're subtracting $5 from it. For the 10% discount, I use D for the discount function. And you can see here that the large pizza is going to cost an X amount minus whatever the 10% is of that amount. And in general, you could think of it as 90% of the original amount of the large pizza. Now, this gives us two functions. It gives us the coupon function and it gives us the discount function. Now what we need to do is create composite functions that represent these two scenarios. So before we can figure out how to answer the question, which is how much more would you pay for a large pizza if the cashier applies the coupon first. So before we can decide that, we have to figure out what the functions are based off the different ordering of applying the discounts, either coupon or 10% discount first. So your next task is to create two separate composite functions. When you finish doing that, come back and see if you've created the correct composite functions. Now what I've done here is I've created my first composite function where I'm taking the discount first. Now if you need a little help with this, if you went back to your key concept summary box on composition of functions, you would see that whichever function is on the inside of the other function is the part that is being evaluated first. So if I were actually taking my 10% discount before I actually applied the $5 coupon, this is the composite function that would represent that scenario. And you see here it would be 0.9x minus 5. So now I need to create a separate composite function that would actually represent me taking the coupon off of the pizza value first before I apply the 10% discount. So that's what I'm going to set up next. So now you can see here I've kind of reversed this composite function from the original one that I made. And I'm going to apply the coupon first. So the large pizza is going to subtract the $5 first. Then I'm going to apply the 10% discount, which is effectively 90% of that entire price. So we have that composite function. Now, here's the thing. In order for us to answer the question, how much more would you pay for a large pizza if the cashier applies the coupon first? We need to take that composite function and subtract the composite function of the discount first, and so then that would give us our difference in price. So let's go ahead and take a look at that. Okay, and what you can see I've done here is I've taken my coupon first composite function and I've subtracted my discount first composite function. Now keep in mind when we're doing function operations and we're subtracting, we have to subtract the entire function, which means we have to use parentheses here. And in the process, what happens is the 0.9x cancels out. And so the difference is 50 cents. And so we would actually pay 50 cents more for the large pizza if the cashier applies the coupon first. So a lot of times you may go somewhere and see someone using coupons and using sales values and may not think that it makes much difference as to which in the way they apply it, but it actually can. And of course, in this particular situation, we're talking about a little bit of money for a large pizza, but it could be significant if you were buying cars or high price electronics or things of that nature. Now, if you're unsure of whether you did this correctly, you could actually plug numbers to test it. You could simply make up a price for a large pizza, let's just say $20, just to make it easy. And then do the actual mathematics of applying the coupon to $20 versus applying the discount to the $20 pizza and see how the difference comes out. So, but that is a good example of an application problem for composite functions.